Yeah. And I don't have to do anything. Great. Hey, everyone. I'm Dan. I'm a software engineer here at the Allen Institute. Previously worked for the International Brain Laboratory. Nice, thanks. And I'm going to tell you about trajectory planning a little bit, and mostly about the tool that I built for trajectory planning called Pinpoint.
Whoa, you gotta switch to focus on content instead of whatever this is.
That's okay. I'm going to take less time than my allotted slot, so we're going to catch up.
Immersive space is not one. I don't even know how to do it. Okay. I'm so sorry.
Okay, so Pinpoint is a website you can go to plan mostly NeuroPixels recordings right now in the mouse and a few other brains, which I'll show you. The idea is to give you a sort of intuitive 3D space to play around sticking probes in brains and figuring out where those probes are going to end up, whether the geometry of your probes is going to work, and make it as easy as possible. So a few goals that I have in general for building Pinpoint and for trajectory planners. I want to give you, as an experimenter, the stereotaxic coordinates that you need to hit your target region. And there's big caveats with that goal. So brains are variable across animals. Experimenters are variable in their ability to precisely target reference coordinates like bregma. So we know there's a lot of error in this, but we're going to give you our best estimate based off the atlases we have, and hopefully in the future off of better warps of those atlases to look like your actual mouse's brain. And I'll come back to that later in the talk. I also think these sort of intuitive 3D tools help people learn brain anatomy. When I first stuck a NeuroPixel probe into a mouse, I missed V1 because I just drove straight into the hippocampus. And that's just because when you first play with these things, you don't understand where you are in the brain. So one of the things we've done with Pinpoint is that you can sync it up with your manipulators in real time. You can watch your probe drive into the brain and see where you are as you do that. And the idea there is you can't make the mistake that I made because you know exactly where you are in the brain. Pinpoint is also supposed to help you keep track of your experiment planning and help you not make mistakes like crash things into each other or lose track of where an experiment was done. This is only half working right now because we're in the middle of upgrading Pinpoint, and I'll mention that at the end. And the last thing we would like to do is use automation to speed things up for you. There's a dedicated undergrad at UW who spent the last 3 years connecting Pinpoint to the manipulators that run in your rig with the goal of making it so you can be sort of hands-free, especially as probes get driven down into the brain. It just frees up time for you to walk around and do other stuff. Okay, so let's play with this thing. So if you go to pinpoint.allenneurodynamics.org, you'll find yourself on this webpage. Maybe don't do it right now, maybe do it a little later. I'm just going to explain a little bit about the controls and walk you through a little bit of how this works. So the mouse control, or the camera controls, you can left click anywhere and drag to move the brain around. It's a little slow, of course, because it's running through a screen share onto another computer, but hopefully you get the idea. You can zoom in and out with normal mouse zoom in and out. And then on the right side, you can drop new probes in the scene through this little menu. You can see we're a little limited on probe options right now, and we're trying to make that easier, make it possible for you to add your own probes with their own geometry. So let's say that I'm targeting primary visual cortex in the mouse. I can search for that region in this little area search bar, pop it up on the screen so we can see where it is. And then I can drop a 1.0 NeuroPixel probe. And the idea here is that I'm going to stick it into visual cortex and plan an insertion there. If you zoom way out, you can see the full geometry of your probe. Here we're using the sort of standard Sense Apex insertion rod. We'd like to make it possible for you to swap this out with other things. This is kind of hard to do. It's a goal I have for the long term. But at least you have this one, and you can crash probes into each other and understand sort of the geometry of your setup if you're using SenseApex manipulators. Okay, zooming back in. The simplest way to plan an insertion is to pop up your target region and then use this little drop-down arrow that'll snap the probe tip to the center of the region in the 3D scene. And then I'm not going to give you all the details now, but you can go and watch the tutorials to understand what I'm doing. But basically, I'm going to use keyboard commands to drive the probe down into the brain. And you can see on the left side, we can see where all of the channels on the probe are ending up and what region they're going into. And you can change, right now we're seeing the sort of full length of we're seeing the first bank of the probe at the bottom, the little white region that's highlighted down there. I'm not sure if you can see that very well on the side here. You can change what recording region is active and see more or less of the probe on the left side. On the right side, there's this sort of in-plane slice at the top right, which is just a cut through the brain in plane with the electrode face. And we're looking at the electrodes right now. The idea there is to help you orient to where you are in the brain. There's other keyboard controls that let you tilt the probe down, move the probe forward and back along the AP axis, and basically set up the scene the way that you want for your recording. And of course, I can add a second probe or a third probe and see whether a possible recording will be doable. So far, so good. Anybody who's coming tomorrow, you'll have plenty of time to play with this and learn the controls and test out different ideas for insertions that you might actually be interested in doing. So I won't do this too much right now. The main thing I want you to look at now is in the bottom right, there's this little probe panel here. It's probably too small for most folks to see, but the APMLDV coordinates that are spit out there are the coordinates you need to move your probe to relative to Bregma to perform this insertion. So right now we're minus 4,000 micrometers posterior of Bregma, 2.5 micrometers to the left. Then we go down to the surface, and then there's a depth value here. I think it's 4,000, so we would drive 4,000 micrometers down to recreate this insertion in an actual mouse. And of course, this is not accounting for variability across animals. That's the basic idea for pinpoint. Okay, so yeah.
So how to manipulate the angle with the prop?
I was tapping keyboard keys that lets you basically shift the angle of the probe. And the commands for doing that are in a help menu. So if you hit escape, it shows you all the keyboard commands and how to control them. But again, this is something, we have a bunch of tutorials on the website. And if you're coming tomorrow, you'll have time to do this. So I don't want to spend too much time on it. Any other questions? Yeah.
So for this, there is a some device configuration is essential. As you were saying, you can connect it with manipulator, right?
So you don't have to, right? So you can plan an entire experiment just on the web through the Pinpoint UI, and then take those stereotaxic coordinates and then go recreate them on your rig, totally separate from Pinpoint. If you want to, you can also connect Pinpoint to your manipulators and have Pinpoint actually control the manipulators for you. But this is sort of like advanced mode.
But is that like specific to any stereotaxic model or?
Yes,
yeah.
Right now it only works with SenseApex, the UMP3 and UMP4, and new scale. I think all the standard new scale manipulators. And we're talking with other companies like Scientifica about connecting with them as well. But that's something, if you're coming tomorrow, Kenneth will be there and you can talk to him about manipulator setup. Okay, so very quickly, there is one built-in default transform for the CCF, which makes it more like an actual mouse's brain. If you've ever done a recording in a mouse and you trusted the CCF and you tried to go to a very ventral region, you actually crash into the bottom of the skull when you do that. And that's because the CCF is too tall, and it's too tall and it's squashed a little anterior posterior. And so we have one transform here. It's based on the MRI, anatomical MRI of a bunch of live mice that helps to fix basically that error. I wouldn't trust this transform to be representative, of course, of your mouse. So anytime you're close to the edges of the brain, you should always be more cautious than when you're just driving into V1 or something. And we don't have to look at this. You can look at the website if you want to know more about how these transforms work and how the spaces are defined. Okay, so a little bit of information about robotics. So here, this is just a video showing Pinpoint actually controlling a manipulator in real time. So this is the idea, trying to make it easier for people to step back from their rig and let the program do things for them. So we're at the point right now where you have to manually insert through the Dura, but you can hit a button after that and we'll drive the rest of the way down to your target region for you and save you a bit of time. Depending on your manipulator, some manipulators do that for you anyways, but we do it and you can watch what's happening as you drive down, which I think is a little helpful. So the idea here is Pinpoint talks back and forth with your hardware. And we can also, this is Kenneth who does this, you'll meet him tomorrow if you're coming. And eventually the goal is to close the loop here, get cameras on the rig that can see what's happening, that can see your craniotomies, and can actually watch as you punch through the Dura and make sure your probe isn't about to break or something. So that's to do in the future, in progress with people here at the Allen Institute and with Kenneth at UW. The other thing we can do is you can forward anatomical information from Pinpoint to Spike GLX and OpenEFIS to show you where individual channels are in the brain. So this is a second source of information that can help you understand how far down into the brain you are, especially when you're looking for those electrophysiology features that tell you that you've crossed into the hippocampus, for example. This is just another source of information. The anatomical information from the CCF basically says, you know, you should be near the hippocampus soon, or you should be passing through a ventricle or something. And again, this is something we can play around with tomorrow if somebody's interested in seeing it. Super quickly, we rely on atlases that come from BrainGlobe. So you can actually swap what atlas is shown here. There's a bunch of other options. You can plan in the human brain, the zebrafish, the prairie vole, cavefish, whatever you want. I'm a little disappointed at this point. I've given this talk 3 times now, I think. And every year, someone asks whether we have a macaque atlas. We don't. Instead, we have a cavefish. The cavefish is tiny, but I think it's really funny that this is here at all. So if I can drive this in. Yeah, so if you're doing cavefish recordings, we have you covered. And I don't know why the macaque folks don't want to spend the time. All you need to do is put your macaque atlas in the BrainGlobe format. It'll immediately work in Pinpoint after that. Okay, so we pull atlases from BrainGlobe. We put them into a Unity game engine wrapper, basically. We build on top of that a rendering tool called Urchin. Urchin is used to build a bunch of fun websites like the NeuroPixel Ultra viewer, if you've ever seen that, and then and other fun videos. And then Pinpoint is built on top of that. I would encourage you to check out Urchin if you're looking for a 3D renderer as an alternative to Brain Renderer, basically. To use Pinpoint, you can go on the web, pinpoint.allenneurodynamics.org. You can also use it on Steam. This is the easiest way to run it on a Windows or a Linux machine. The only reason we push people to pull it from Steam is because the updates are easier for us to handle and push out to you. It does run offline, by the way. That's a regular question. You need to run it once connected to the internet. It caches a copy of the atlases in the background. And then after that, you can relaunch it without being connected to the internet. We have a bunch of documentation and tutorials on virtualbrainlab.org. And there's a bunch of videos there and text tutorials that walk you through how to use Pinpoint. And we'll be updating those in the next year because right now we're trying to roll out a new user interface for Pinpoint. And that's it. I can answer any questions, but I can also just hang out while folks get coffee, and you can come chat with me about Pinpoint. And of course, we'll talk more tomorrow if you're coming there. Quickly mention that almost all of the work to build this was collaboration with the International Brain Laboratory and with Nick Steinmetz's lab at UW. So a big thank you to the folks there. Thank you.
use different type of probes, or it's just like depending on the?
So when we first built Pinpoint, we did a really bad job of making it easy to put new probes in. So right now, the way you add a new probe is you email me with the model of your probe, and I do it for you. And you can see that I didn't get very far at doing this because it's slow. So the new system will be, hopefully in a few months, there's going to be a GitHub repository where you need to put some metadata about your probe, and then it'll build the probe into Pinpoint for you. So it's something we've been working on for a year or so. It should be working soon. Ideally, it will work with Spike interface. So if your probe is described in the Spike interface system, then it will also just exist in Pinpoint automatically for you. The much harder part is if you need 3D geometry attached to your probe, this stuff up here, you need to know how to use Blender and properly line up your 3D models relative to the tip position of your probe. Otherwise, they won't show up in the right space in Pinpoint. So the short answer is no, there's not really any other probes than NeuroPixels. Sorry. But just a reminder to everyone, you don't need to know your probe geometry to plan an experiment, right? You can use one of these little pipette things. It's just a line in space. But as long as you know the length of your probe recording region, this is enough to plan your recording or to know where you're going in space. Same thing, sometimes people ask, like, can I plan viral injections in Pinpoint? And the answer is, of course. Like, you don't need to know the geometry of your viral injection system, right? You just need to know where you're going. Where is the final tip location need to be? Yeah?
I have a question for Bruno, is that okay? Okay. Bruno, do you have any idea if it's possible to switch mid-session from head fix to 3D moving in the modular behavior test that you showed in a quite simple way, like one line of code?
Yeah, I'll need more details exactly what switching from head fix and 3D moving means. Like in theory, there's nothing preventing you from doing that. Yeah, I need to know a little bit.
Okay, so alright, the copy.
Yeah, maybe. Yeah.
Thanks.
Can you change the depth zeroing at different AP and ML measurements within Pinpoint?
The depth zeroing is going off of the surface of the brain. So if we go back, let me just show you what it looks like. Whoops. If you switch atlases too many times, eventually you run out of memory in the browser. That's what the error was. So if you kind of watch carefully as I insert the probe, we flip to, so as you're inserting the probe, oops, it's way too fast. The zero just started as we went through the surface there.
Okay, and then it self-zeros then the farther ML you go, or
yeah, so it's going to zero off wherever the surface of the atlas is, and that's going to be true for all the atlases. You can't reset the zero inside of Pinpoint.
Okay.
That's a kind of obvious thing we should probably add. Yeah. You can, when you're using the automation system, reset the zero to the real zero of your actual brain that you're working with. Okay. But it's not built into Pinpoint here.
Just the channel maps from your pixel. Is it possible, like in the future, like to load them essentially and really see like what bunch of channels are where? That would be super useful, I think.
Yeah. So the big problem there is that it's kind of a pain to load files into the browser and have them accessible inside of this thing. Partly it's because it's being built on Unity, and Unity makes it hard to do this. So the answer is yes. We should probably build that in, and I think there's like several issues on GitHub of people asking me to do that. So I'm totally aware of it. It's just low on my priority list. Yeah. Coffee break.
Coffee break.
Thanks, everyone. Google?